Hey there, scientists. And today we are going to grab our lab coats and our goggles and talk about how we can find patterns on Earth by observing the sun and the moon. Let's get started with our essential questions. Now, let's talk about our essential question. Remember, essential questions in science and in different lessons can help us think about what we already know about a topic, and it helps us connect to new ideas that we're going to learn today to help us produce a new thought about the topic. Our essential questions will be focused on our different science topics. So look for key words. In those keywords, the minute you see them and recognize them, I want you to think, what do I already know about this topic? Once you have that in your mind, you want to look at the question again to see what we're trying to answer today or what are we trying to answer about that topic. It's important to remember that an essential question is like a goal as well. By the end of our science lesson, you should confidently be able to answer the essential question. Let's go over our essential question for today. When we talk about patterns of the Earth, we're going to be focusing on 3 essential questions. The essential questions for this topic are as followed. Listen to me first. How can we predict how the patterns we observe on Earth will continue? Say that one with me. How can we predict how the patterns we observe on Earth will continue? Let's look at the second one. Listen to me first. How do shadows change during the seasons? Say that one with me. How do shadows change during the seasons? And the last one. What is the sequence, order, of the moon's appearance each month? Say that one with me. What is the sequence, order, of the moon's appearance each month? We are going to be talking together about the winter and summer solstice, which is the longest and shortest day of the years. Let's watch a video explaining where and when that was going to happen in 2018, and then I'll tell you when it's going to happen this year.
Summer is officially here, which means it's time for summer solstice, aka the longest day of the year. This year, that's June 21st for the Northern Hemisphere, bringing the longest day and shortest night to 88% of the world's population. The opposite's true for the Southern Hemisphere, which will now experience their winter solstice and shortest day of the year. You might think since it's the longest day, the Earth's actually closest to the sun. It's not. The Earth rotates on a 23.5-degree tilt towards the sun every day, making a full orbit around the sun once every 365 days and 6 hours. As the planet rotates on its axis, the summer solstice occurs when the North Pole reaches its greatest tilt toward the sun, and the sun shines down longer due to its positioning. As the planet rotates on its axis, the summer solstice occurs when the North Pole reaches its greatest tilt toward the sun, and the sun shines down longer due to its positioning. There are areas within the Arctic Circle that'll see the sun up for 24 hours today. Now, while most of the Northern Hemisphere doesn't catch the sun for an entire day, there's still plenty of daylight to soak in. Most places in the U.S. see the sun for about 14 to 16 hours on summer solstice. New York is expected to get about 15 hours of sunlight this year, while Austin will have 14 hours to bask in the summer rays. But the extra sunshine doesn't necessarily mean it's the hottest day of the year. On this day, the land and oceans absorb some of the energy from the sun, store it, and release it as heat at various rates. Thanks to spring temperatures, the land and oceans are still fairly cool, so air temperatures won't reach their maximum on summer solstice. Eventually, the land and oceans release the stored heat back into the atmosphere, meaning the hottest temperatures typically hit in August or later, depending on your latitude. And it's been a day long celebrated from monuments at Stonehenge in England to Karnak in Egypt. People around the world have been taking note of the summer solstice for thousands of years. Folks still gather around Stonehenge to watch the sun rise over the structure's heel stone and hit the altar stone dead center. So whether you're planning on going for a nice walk, joining a festival, or dancing the night away, be sure to enjoy the extra sunshine. The days only get shorter from here on out.
When we talk about the summer and winter solstice, we're talking about the longest and shortest days of the year. The reason these different solstices happen is because the Earth is on a tilt as it goes around the sun. So because we're going around the sun, we're getting less light or more light in certain hours. If the Earth wasn't on a tilt and it just spun around perfectly straight, we would get the same amount of night and daytime as we would everywhere. So it would be 12 hours of nighttime and 12 hours of daytime. But the Earth is tilted over. So that means our days are sometimes longer in one hemisphere than the other. And as the Earth also goes around the sun, the hemisphere that is lit up is not always the same throughout the year. We saw that other day in our exploration. Some places on the Earth sometimes get 0 hours of daylight, and sometimes they get 24 hours of daylight. Now, we've talked a lot about daylight and a little bit about the solstices. The next solstice is coming up is our winter solstice. The winter solstice is on December 21st, 2022. So this will be the shortest day because it will be the shortest amount of daylight that we see in one day throughout the entire 2022 year. Another key element, the moon. The moon is something that also rotates around the Earth. So as the Earth is going around the sun, revolving around the sun, the moon is also going around the Earth. Now, because the moon is going around the Earth, sometimes the moon sees no sunlight, like when it's on the opposite side of the sun. And sometimes it sees sunlight on part of it, or it might even block the sun a little bit from the Earth. All of these different ways will provide a different cast or a shadow on the moon. And those are going to make up our moon phases. Today, you guys are going to explore the different moon phases as a class. You're going to see what happens when the moon is directly behind the Earth and what happens when it's directly in front of the Earth and between the sun. How much light is it getting, and what do we see on Earth when we look at the moon like that? While you guys are exploring today, make sure to take notes and ask questions if you can't actually see what you're looking for. You're focusing on the moon phases. Good luck, scientists, and I'll see you.